So we're working on this project called DevSecOps Secure Cloud Enclaves, and our mentors are from the Jackpine Technologies Corporation. So what does it mean to have a secure system? Is it limited to having a firewall or a strong password for your system so that the attacker can't enter into the system? But what do we do when the hacker is already inside? How do we protect our data in that case? So firewall doesn't clearly cut it anymore, and we need a solution beyond the firewall. And a solution could be logging all the events extensively, logging system critical events, logins, actions on the system, providing secure storage, encrypting the data. So how does the Jackpine Technologies go about doing this? So they have this product called Concert, which is a cloud and security orchestration product, which enables the user to manage their VM safely by just clicking a button. It has the functionality to install and set up services automatically, and it's just as simple as clicking a button. And they're providing these services in an AWS background. So how are they doing it? Concert creates a cloud space in the MOC environment. They basically create a NAT gateway, one for the user to access, one for Concert admins, a firewall around the cloud, and routing between the NAT and the VMs. Since the developers at Jackpine are the only admins, it allows them to design the environment in such a way that all of the traffic and system logging can be performed. So we've made an attempt to stand up to our solution within their framework. So our solution involves implementing similar features that they're providing in AWS in an OpenStack environment, specifically in the Mass Open Cloud MOC environment. So we're doing this by creating shell scripts to automate setup of all our logging infrastructure, securing object storage, and script for an intrusion prevention detection system. We've also provided a method for encrypted interaction for a user with the Ceph object storage, and we've provided a wrapper around the S3 API.
Moving into the overall logging architecture that we've set up, you can see that we have a bunch of various services over here that are sending their logs, as well as the system, to the normal Linux log directory /var/log. Within this, part of the Elastic Stack FileBeats, which is just a log forward I'll get into, reads logs from var log and forwards them onto Logstash, which is our log processor. It filters the logs and then sends them to a secure location on the VM, which we've designated to be this directory /store log. Over this directory, a cron job, which is nothing more than a daily or hourly process, forwards these logs using our interaction with the Ceph object storage to our secure object buckets. So getting into what each of these parts are specifically, what does it mean by extensive logging? So what are we actually logging in this directory? Any hosted services on the VM are going to send their logs to a folder within the log directory. This can be things like HTTPD, also the things that we're setting up like Logstash, FileBeat, and fail2ban, which we'll get into in a little bit. Varlog messages, which is just general VM activity. Anything that goes on within the OS is things like cron jobs and other stuff like that output their logs here. Secure, which has to deal with any logins or authentication actions within the VM. We're logging bucket events, which is basically any action that's taken on our secure buckets in order to maintain that our data is in there safely. Any OpenStack events, which is interaction with OpenStack through the OpenStack command line interface, and any startup logs or things that Linux creates when it actually boots up the initial CentOS VM. So what is FileBeat? It's simply part of the Elastic Stack. It's a log forwarder, so it'll sniff all the log directories we specify in a configuration file and forward the messages to Logstash. Logstash is our log processor. It takes the log input from FileBeat, filters the logs by removing any unnecessary information. This can be things like random tags that are by default put into the logs that aren't really necessary when we're doing an analysis of them. This information that we keep is things like the user, when the log was taken, the timestamp, and what the actual message of the log was and where it came from. And then it outputs the filtered logs to a secure location on the VM that only the root user can access and modify. A cron job is just a process that's configured to run on hourly on the VM. In this case, like I said, it's configured hourly, and it's just simply calls a Python script to take the log files that are in storelog that are dated and write them to our secure buckets. And to get into what these secure buckets actually are, I'll pass it off to Avantika.
So how do we ensure the data is stored in a safe way? When we're storing data with third-party cloud providers, what kind of control do we actually have on how secure that data is? Well, there are some things we can do, and what we can do for bucket security is only allow authorized accesses to the buckets, make versions of the objects if they're being modified, and keep track of all of those versions or modifications. We can encrypt the objects, and we can generate logs for all events that happen in the buckets. But we as developers know that these features need to be enabled for buckets to be secure. How do we ensure that these features are actually used by the users? For this, we've come up with an object storage API, which is just a way for the users to interact with Ceph object storage without having to worry about security. So we handle it all for them. What we've done is we've created a wrapper around this Ceph S3 API in Python, which has an interactive CLI for the users to use to store their data. It automatically enables object versioning on creation of a bucket, and it manually generates logs for all events, be that for reads, writes, modifications, deletions, for everything. And it also encrypts and decrypts objects. But encrypting and decrypting is an entire world on its own. There are so many things that we need to keep in mind while we encrypt. So first off, why do we encrypt? We should never store anything remotely in plain text. That's because we have no control over the security features of the cloud provider that's providing storage. And we should do our best to make sure that if there's a breach on their end, our data is not compromised. So we encrypt the data before pushing to buckets, and we decrypt it before serving it back to the users. And for encryption, we need keys. So these keys are also never stored locally, because if a hacker gets into the system, they shouldn't be able to access our keys. So for this, we use Barbican, which is OpenStack's key management service. And what it does is at the beginning, when a VM is initialized, it creates keys. And in the object storage API, it pulls keys from Barbican and uses those keys to encrypt or decrypt the data that's going up or down from the buckets. We also enable in-transit security. TLS SSL is enabled by default. By that I mean port 443 is on, and this provides hybrid encryption. Another thing we do to ensure security is install fail2ban on our VMs, which is nothing but an intrusion detection system. So what it does is it scans for brute force login attempts in real time, and it blocks the IP addresses of any systems that show signs of attacking ours. So this program works in the background, and it continuously scans the log files as well in case there are any unusual login attempts or security breach attempts.
With that being said, let's now discuss the overall architecture, sort of what we've done. So what happens in the setup, in the creation of a VM? Basically, dependencies are installed. So everything that we need to run our infrastructure is installed, scripts are downloaded that both install and set up our architecture, as well as necessary config files and YAMLs, configs, anything along those lines, as well as services such as FileBeat and Logstash and Barbican, and all of that is launched every time a VM is created, as well as object and log encryption keys are generated and installed. They don't actually expire, so they only need to be done once, as well as EC2 keys, OpenStack credentials, tokens. All of those are set up as environment variables. Functionality, so along that line, so users can store sensitive data in S3 buckets as described earlier. Security features include logging everything that is vital that occurs within a VM. So services, messages, bucket events, operations, anything along those lines. And IPs that tried to brute force are banned and blocked from no longer being able to, as well as secure object storage. So buckets are versioned and objects are encrypted and decrypted so that they're not stored locally as plain text, as mentioned earlier, and all bucket events are in fact logged.
Yeah, and just a reminder that all of this is done through a bunch of setup scripts that we've created that are just downloaded at the onset of a VM and run, and this whole picture will be set up automatically, which was one of the main features of our project.
And now, with all that being said, let's talk about our experience with this project. So this sort of summarizes a good issue of what we've had to deal with, and let's move on to what was tough. So object storage was initially tough. So connecting to the MOC, being able to figure out what sort of S3 version, figuring out it was Ceph versus Amazon, and logging bucket events as well. OpenStack CLI logging was also turned out to be an issue. Connecting to Concert to the MOC became an issue that was unfortunately covered multiple sprints. The limited documentation, which is always an issue with, with services such as this, as well as learning how to make separate services all work together in one cohesive manner, which is the purpose of our project, was something that was turned out to be difficult. So what was missing from our project? So standing up our own OpenStack instance. So, excuse me, we ran on the MOC, but not as admins, and we were not given admin privileges. So being able to tinker was not something provided to us. Being able to set up like backend config files and stuff like that, we were not able to do. We were sort of limited as customers of the MOC rather than admins of it. So we were not able to do such things as rotate accounts and credentials because we were stuck with our own. And enabling standard logging is also something we were not able to do because we did not own the cloud space we were operating on. Yeah, we just had limited permissions in that way. So what extensions could we bring to this? So one thing we could do is separate logging buckets for different users and different VMs. So having one centralized VM that has all the logging information and is pushing it to buckets itself and is tied to all the VMs within the cloud space. And Logstash and FileBeat is running on all of those, collecting the logs, pushing them to the centralized, and then pushing that into the bucket itself, as well as standing up security features in the MOC backend. As we said earlier, we're not able to do that as we are not admins ourselves, but stuff like logging configurations and monitor and rotations of keys would be awesome to do. So what have we learned? We've learned a broad stroke skills in API creation, shell scripting, automation, for sure automation, and then as well as all the previously mentioned services such as Barbican, LogMeet, FileStash, as well as the security standards. So what does it mean to have a secure cloud? Sort of understanding the purpose of our project as a whole was definitely something we learned. And now, and also how and where to ask questions, how to phrase them, who to ask, who to who knows, all stuff like that. Yeah.
Hey, so we're here for the demo portion of our video. We are on the concert UI here, as you can see, and we launched a CentOS 7.5 template with all of our scripts loaded onto it. And you can see that they were all completed, so this should be the secure interface that we have created. So if I connect, we're going to use SSH to get in. And what I'm going to demonstrate in this demo is our object storage and encryption. So first we'll log on to the root and we'll go to a directory that I've just created for the purpose of this test. What we have in here is just a dummy test file called hi.txt, and what it has written in it is hi, as you can see. So now the command line is moved to the bottom of the screen, but we're going to run the script listed in our documentation. That is the interactive interface to our object storage API, and as you can see, it's starting up. So when we come into here, it'll prompt you to continue. We will. First, let's list the buckets that we have available to write to. So I typed in option 1, and it'll show us all the buckets that are connected to our MOC account. We're going to be writing to API testing bucket, so let's 5 for upload to bucket, enter the key. It's going to be hi.txt. This is going to be the file name you want to store it in the bucket. Enter the path. This is where the file is on our computer, so it's /test/hi.txt, and then finally the bucket name is API testing bucket, and we're going to upload it like that. So we're going to leave this for a second and go over to our concert. So as you can see, we have the API testing bucket here, no items to display, but if we reload the page, we can see that hi.txt was in fact uploaded. Just to kind of verify that it's encrypted, if we download the file and try and open it on our computer, we can see that it's just a bunch of garbage that no one would be able to tell what was actually written in this file. But let's further go on and show that we can retrieve the file back to concert. Do I want to continue? No. First I'm going to go in here and remove the hi.txt file just so we can show that it's going to get downloaded. So we can open up the object storage API again. So we're back. We're going to continue. We're going to download from the bucket, enter the key that we want to download. It's going to be hi.txt. We'll store it in, this time, I don't know, hello.txt, and then enter the bucket name. This is API testing bucket. So it's taking a little bit of time to download and decrypt, but we won't continue. We'll look at our thing and see that hello.txt is here, and now if we VI into this, we can see that the hi is back, so it was successfully decrypted. Now, just to show a little bit more, if we now go to our log directory, /var/log/object store, which is the directory where we store all of the data on what we're doing with object storage, we can look at this file. Object store.log. And if we go to the bottom, we can see that our transaction would have been monitored. So if we can see at Friday, May 3rd at about 2, well, this is GMT, but at 11:38, we downloaded the file right here, path testing bucket.hi.text and downloaded it onto our computer right here. So thank you.